This is section 7.1, and today we're going to be talking about the Pythagorean Theorem. All of chapter 7 focuses completely on triangles, so we'll be doing a lot of different things with triangles. And the first one starts off by talking about Pythagorean's Theorem, which you may have heard of before. It deals with a right triangle and how the sides are related to each other. If you have a right triangle, then the sides can go a squared plus b squared equals c squared. So whichever side is the hypotenuse, and draw through your 90 to find your hypotenuse, that side by itself squared equals the other two squared. And we'll do some examples so you know what that looks like. A and B are called the legs of the triangle, and C is called the hypotenuse. So first example just says, can you label the legs and the hypotenuse and then find the missing side length of each triangle? So the 6 is the leg, the 4 is the leg, and the x is the hypotenuse. I know that because if I were to draw a line through the 90-degree angle, it always points to the hypotenuse. So using the two legs, go 6 squared plus 4 squared equals my x squared. The hypotenuse is always the one by itself, no matter how I write the formula. No matter which way I set this, the hypotenuse is the one that's always by itself. So doing 6 squared, I get 36 plus 16 equals x squared. So I'm looking at 52 here. And then you still have an x squared, so to undo that, you're going to square root both sides. So I'm just squeezing this in here. You're going to have the square root of 52, which if you used your calculator and gave the decimal answer, you would be right around 7.2. Number 2, I'm going to squeeze that in there. Number 2, again, drawing through the 90-degree angle points you right at your hypotenuse, so that makes these two the legs. And it doesn't matter how I use the formula, the hypotenuse just has to be by itself. So I'm going to do x squared equals 8 squared plus 6 squared. And I've got 64 here plus 36, which gives me 100 x squared. Square rooting both sides, I get 10. Last one, hypotenuse. Both of those are legs. So looking at x squared plus 3 squared equals 5 squared. Again, no matter where the x is, no matter how I set up the formula, the hypotenuse has to be the one by itself. So even though my x is over here this time, it still has to be my hypotenuse by itself for the formula to work. So I have x squared plus 9 equals 25. Subtracting the 9 over to the other side, I get 16. Square rooting that, I get 4. And that is the gist of Pythagorean's theorem. Just a couple of more examples here that are in word format, so a couple of word problems. A 16-foot ladder rests against the side of a house. So here's my house. Here's my ladder against the house. It's 16 feet tall. Or I'm sorry, yeah, the 16-foot ladder. It's 4 feet away from the house. So how high above the ground does the ladder reach? So going through my 90-degree angle, the 16 is the hypotenuse, equals 4 squared and the x squared. So doing 16 squared, I get 256. 16 plus x squared. Subtracting my 16 from the other side, moving it over, I'm at 240, and now I need to root that. So the square root of 240 is about 15.5 feet. Next up it says find the area of an isosceles triangle. An isosceles triangle means that two sides are equal, and they kind of gave me that info by telling me there's a 13, and then the third side is a 10. So this is my isosceles with these two sides being equal. They want me to find the area. Area, if you remember, is 1/2 base times height. So I need the base of the triangle, which is 10. Height of the triangle should be measured straight up and down. Lots of students will say 13 is the height, and then I kind of remind them, you know, when you go to the doctor's office, do you stand with your feet away from the wall and then lean against the wall to measure your height? We measure height going straight up and down, so we need to find that height right there. So what I kind of did was just chop this into a right triangle with a 13 and not a 10 because 10 was the whole thing, but in an isosceles, if I drop that straight down, I could chop it in half. So we're looking for that third side. So we'll quick do a little Pythagorean's theorem to figure that out. The 13 was my hypotenuse, so that's why it's by itself. And doing 13 squared and bringing that 5 squared over, I end up with 144. And that means my x, my height, is 12 for 60 meters squared of area. A Pythagorean triple is a set of 3 positive integers that satisfy the Pythagorean's theorem. That means there's no decimals. A couple of common ones that we've used today already is this one. This is a 3, 4, 5 triangle, so a 3, 4, 5. It works perfectly in Pythagorean theorem with no decimals. Another one we did was right here, a 5, 12, 13. That is another Pythagorean triple. There are lots of them out there. You can Google it, see the list. There's a bunch. Those are the two that you'll probably see the most. A couple more examples, getting a little more difficult here. So we've got these squares. All the sides are equal, all those little tick marks. And what they're just trying to tell you is that this is an 8 and an 8. So we're going to do Pythagorean's theorem. That's a 90, so drawing through it, my x is the hypotenuse, which means it needs to be by itself. So I have x squared equals, and then 64 and 64 gives me a 128. And the square root of 128 is about 11.31. Next up, we have to solve two different triangles in order to get to our x. So first we're going to have to find this side right here. We'll make it be a y. And once we find that value, then we can come over here and figure out our x. So we'll focus on just the bottom triangle first. Hypotenuse is 12, so 12 squared equals 6 squared plus y squared. And 12 squared is 144. And then subtracting your 6 squared over leaves you with a 108. And the square root of 108 is about 10.4. So now doing Pythagorean's theorem with the top triangle, hypotenuse is 14. I have 10.4 squared, and I have x squared. So doing my 14 squared and minusing off that 10.4 squared, oops, gives me an 87.84. Still needing to root that yet. So the square root of the 87.84, oops, struggle, 9.37. And with Pythagorean theorem, the nice thing is you can kind of look and see if your answer makes sense. On this triangle, the hypotenuse has to be the longest, so as long as we get an answer that's less than 12, we're good. So 10.4 is pretty reasonable. It's definitely the longer side to 6. 9.37, if this is a 10 and that's 14, again, this has to be the longest side, so our final answer can't be any longer than 14. Ended up being a 9, which is probably pretty darn close. One more, we're going to have to do 3 different Pythagorean theorems to work our way to that x. We'll start with this little one right here. 24 is my hypotenuse. And I'll just throw an x right there. Well, I won't. We'll make it a y. So doing 24 squared and bringing that 16 squared over, I'm ended up with 320. And then the square root of that is about 17.89. So that's this side right here. Doing Pythagorean's theorem again. I'll put a z there. So z squared equals 14 squared and the 17.89 squared. Gives you total 516. And then you're going to root that and get about 22.72. So that's this side. Now we need to do Pythagorean's theorem one last time. So 32 is the hypotenuse. We've got the x that we were looking for originally. My bad, sorry. This should be the equal sign. I'm writing too fast. This is the plus sign. And then the 22.72 squared. So 32 squared and then minus our 22.72 squared gives me about 508. And then we have to root that. So we are looking at about 22.54. So just a lot of Pythagorean's theorem today. Again, I would remind you to draw through the 90, identify your hypotenuse first. That's the number that has to be by itself. The other two get added in no particular order.